what's up YouTube? Mr. Fackenthal here. Today we're going to be doing Chapter 6, Section 2, Representations of Functions. Alright, so we're going to be talking about how we use functions, how we work with them. Alright, this should all be a lot of review for you again, but I'll try to get through it as fast as I can. If at any point you need to pause, take a break, copy everything down, feel free. All right, without further ado, let's get to it. All right, so our first key idea today is we're going to be talking about functions as equations. A function rule is an equation that describes the relationship between inputs, independent variable, and outputs, dependent variable. So let's think about this. This is our function right here, y equals 3x. Our independent variable is our input. Our independent variable is our input. This is independent because we could pick any number. We could pick -2, -4, 5, 6, 100, 200, 300, a million. Anything we want. It's independent because we can pick it, but we're going to plug into the function. It's our input, we plug it into the function. Our output is our dependent variable. This is dependent because this depends on whatever the input is. So if this input is -2, we plug it into y equals 3x, our output is going to be -6. If we plugged in, let's say, 3 as our input, our output would be, well, 3 times 3 is 9. So our output depends on whatever we put into it, on whatever our input is. This is why our input is independent and our output is dependent. Okay, so that's our first key idea. Alright, so example 1 is writing function rules. Writing function rules is a lot like what we were doing when we were writing equations based on word problems in Chapter 5. So, let's start with A. Write a function rule for the output is 5 less than the input. Well, in words, we know the output, that is our y, is our key that it's an equal sign, 5 less than the input. 5 less than the input we would write as the input x minus 5. So our function rule for the output is 5 less than the input is y equals x minus 5. Let's try it again down here for B. Write a function rule for the output is the square of the input. So again, in words, the output y, the output, our dependent variable, y, is equal to the square of the input. Well, our input is x. Always work with the input first and then see what operation are we doing to it. So the input, it's the square of it. So y equals x squared. So our function rule for the output is the square of the input is y equals x squared. Okay, example 2 is evaluating a function. Now you guys should be pros at this by now, but we'll go over it one more time anyway. So we want to know what is the value of y equals 2x plus 5 when x equals 3. So first thing we have to do is rewrite our equation. Y equals 2x plus 5. Then we're going to substitute in 3 for x. So y equals 2, change the colors to make sure you know where we're at, times 3 plus 5. So y equals 2 times 3 plus 5. Well, we know that 2 times 3 is 6, plus 5 is 11. So y is equal to 11. So when x is 3, y is 11. We can write that as an ordered pair, x comma y. Alright, now we have another key idea in here. That key idea is just going to remind you how to use a function table and graph. So a function can be represented by an input-output table and by a graph. The table and graph below represent the function y equals x plus 2. So let's go ahead and take a look at this table. When our input is 1, we would plug 1 into our function over here, so y equals 1 plus 2, so our output is 3. That will give us the ordered pair 1, 3. Then we have our input of 2. We get an output of 4 because 2 plus 2 is 4. And then our input of 3, plug in 3 for x here, y equals 3 plus 5, 3 plus 2, and that gives us 5. That gives us the ordered pair 3, 5. Then we plot these 3 points on a graph over here, just like this, and then we draw a line through the points, just like we were doing with Chapter 4 graphing and Chapter 5.1 solving systems by graphing. Okay, so as long as we can graph from points and a table, you're good to go. This should be a little bit of a review for you. We will need this though in example 3 coming up next. So if you need a little refresher, take time, copy this down. It will be part of the notes. Okay, so example 3 has us graphing a function. First, we're going to take our function, put it into our function table, get an ordered pair, and then plot those ordered pair points and draw a line between them on the graph. So let's start it up. So our first off, our function is y equals negative 2x plus 1. And we're going to use the inputs of negative 1, 0, 1, and 2, just to keep it simple. So our first point is negative 1. Plug negative 1 into our function, negative 2x plus 1, so negative 2 times negative 1. That's going to give us positive 2 plus 1 is 3. Then we plug in 0 for x. Negative 2 times 0 is 0. Plus 1 is 1. And then plug in 1. Negative 2 times 1 is negative 2. Plus 1 is, negative 2 plus 1 is negative 1. And then we plug in 2 for x. Again, negative 2 times 2 is negative 4. Plus 1 is negative 3. Now let's write these as ordered pairs. So we're going to have negative 1, 3. Then we'll have 0, 1, 1, negative 1, and 2, negative 3. Sorry about drawing outside the lines there. So first order pair that we have to plot is negative 1, 3. So we move negative 1 up 3 to put our first point here. Then we'll plot 0, 1. So that's going to be 0 up 1. Our next one is going to be 1, negative 1. And our last one is 2, negative 3. So this would be 1, 2, 3. Now I'm going to go ahead and grab my line tool and connect these points. Connect the points, extend it out a little bit, because our function goes in all directions. So now we have graphed our function, and that's all there is to example 3. Should be a lot of review. And last but not least, we have example 4, which is our real-life application, which is basically what we're going to take everything we just learned and use it to solve a real-life application word problem. So our problem is the number of pounds P of carbon dioxide produced by a car is 20 times the number of gallons G of gasoline used by the car. Write and graph a function that describes the relationship between G and P. So the first thing that we have to do is to come up with an equation based on what the problem gave us. So in words, the number of pounds P, which is going to be our output, so we'll say P is our output, is, which is our magic word for equals, 20 times the number of gallons of gasoline. So 20 times G, our gallons of gasoline. So P equals 20 G. For every gallon of gasoline that we use, we have 20 pounds of carbon dioxide produced. So let's plug this into our function table and get some ordered pairs. So when we plug in 1, when our input is 1, our output is 20. We just plugged in 1 for G. When our input is 2, our output is 40. And when we plug in 3, our output is 60. So that's going to give us the ordered pair 1, 20. Make sure you close parentheses. 2, 40. And 3, 60. Okay, now let's take these 3 points and graph them on our graph over here. So make sure you look at your axes labels. We're counting by halves here. So 1 is right here. So this is going to be 1, 10, 20. This is our first point. 2, 40. So this will be our second point right here. And then 3, 60. This will be our third point right here. Now remember, if we use no gasoline, we create no emissions. And it's impossible to use negative gasoline. We can't have negative gallons of gas in our car. So we're going to start at 0. That means that this is a proportional relationship. So now we use our line tool and connect all of these points on our graph. And we have now successfully graphed our function. That's all there is to example 4. We just to recap, we wrote our equation, P equals 20G, based on the word problem that they gave us. Plugged in our inputs of 1, 2, and 3 into our function table, got our outputs. This also gave us our ordered pairs. These are ordered pairs of what we plotted on the graph, and then we connected the points using our line. And that's all we have for Chapter 6, Section 2. Don't forget to like and subscribe, comment below. Let me know what you think. Bring any questions that you have to class. Alright, I'll see you on the next lesson. Have fun. Happy solving.